All right, we are here with the miter saw, about to show Roger and Kartik here how to cut these boom arm tubes and then landing gear tubes down to size and see if we can come up with a more efficient way to do this as we scale up the developer production. So other than the tubes, you need a ruler and some tape and a pen or some sort of writing utensil that will show up clearly on the tape. So we'll start off with the boom arms, get this longer landing gear tube out of the way. This, if you're buying it like we do, comes in a 43-inch long section from Master Car. And we're going to cut them down to 4.75-inch sections for the base Developer model and the Developer HP, and 6-inch long sections for the Developer XE, which is the middle model of those three. I was about to show how good I was on just guesstimating the 4.5 inches, but I will actually use the ruler to document a relatively good practice as much as I'm failing on getting the tape in place. And the tape doesn't have to go all the way around, just at least on one side. Now you can then hold up the ruler to the edge of the tube. Again, want to make sure the line there lines up actually with the tube. And then I mark just before the that's 4.5 inches. I know my measurements, people. Just before the 4.75 inch line, 4 3/4 of an inch. I think I misspoke earlier. Not the first time, but the second time measuring the length. And then something else to be cognizant of is why don't you just go ahead and tape all the way down the line? I tried doing that first when I first started doing this production, but you have to take into account the width of the blade as well. And if you don't do that exactly, all of your cuts are going to be off. So you really have to mark it one at a time. Once you have it moved into place, you just want to make sure the left edge of the blade is not even touching the line. There'll be a little bit of space because again, once it starts spinning up, you'll see that those serrated bits actually stick out a little bit further than what it looks to be. So I'm gonna call it right about there is good. It is always good to have it a little bit on the longer side because you can always trim it, but you can't extend it after it's been cut. All right. And just always let the tube fall if you have a similar setup. You know, it's very resilient tubing. Nothing is going to happen to it. Not going to fling off unless maybe you have the smallest piece and you don't just go all the way through the cut. Never been a problem in my case, but I guess word of the wise or word of caution.
No, that's proven tough.
Well, so this is, I guess, one other note to make is you want to make sure the blade is already spinning before you go down into the tube. I have worked with a few people here that want to like get the blade right up against the tube and then start the blade. You do not want to do that. You want to make sure the blade's already up to speed by the time you go down and into the cut. All right, we'll do another one of a 4.5 or 4.75 inch section. So we'll have a boom arm for a base model Developer as well as an HP. Then we'll do a 6-inch cut for an XE, and then we'll move on over to the landing gear legs. Food Network style, as I'll continue to say. And the best of all recycling, right, is reusing. Although that's probably a little bit too little of tape to reuse. I do like to reuse the tape as much as we can, saving, you know, maybe fractions of a cent at a time. All right, line pretty much in the same spot. from what I could tell, maybe a little bit closer to the 4.75 inch line than the last one, so I might be a little bit more further removed from the line when I'm making the cut. Again, I'm gonna try to cut just a little bit long, if not on the nose. Starting up the blade. And then typically on the actual surface of the miter saw itself, where I see it's most flat, I just do a check, and wow, on the money. Aren't I great? Rhetorical question. All right, and then like I said, one more cut, we'll do a 6-inch tube for the Developer XE landing gear. Now actually, as Coven is using good practice, if you're doing continuous cuts through like a whole tube or more, I would definitely recommend, you know, wearing one of these like $20 gas masks. They'll protect all like the your lungs from all the fiberglass particulate. And also safety goggles, I think that's pretty good. Also, I will sometimes wear latex gloves. If you've ever worked in an attic, you'll know fiberglass can get in your skin and be an irritant, like me. And so I guess there's more safety equipment than what I'm using in an ideal scenario. Something about not being able to talk while I have the mask on, so everyone has to listen to me drone on. Yeah, you can mute. Again, have a pretty good idea of what 6 inches looks like, so I probably didn't even have to hold up the ruler.
Maybe from next time you have to keep one sample of each different size, so you can mark it directly instead of
like using
the
reference?
scale.
Yeah, yeah. Good idea.
Oh, yeah, so just taking one tube and using that to mark it?
Yeah, like make...
Yeah, so I actually do that, and we do have some pre-cut, but I don't know, sometimes I just get in the habit of marking them. But you can absolutely do what Kartik says. Take one and then just use that to start marking the others.
Yeah.
Or I like to point out, if we're like actually scaling this up for assembly, a lot of the big companies will make like a 3D printed like end stop at the end, and you just slide it all the way down and then like cut it.
Yeah.
That way you don't have to measure anything.
What he said. Big brain Coven. And since we're only cutting one, I'm just going to see where we're at. Yep, right on 6 inches. So on the money for all of our boom arm tube cuts. Now, this is where the length matters much more so on the landing gear. So there's, for the standard Develop Air, 2 different cuts we need to make. We need to make a 3-inch cut for the vertical tube. That's not quite as important to be spot on 3 inches, as long as it's identical to the other tube. So if one's cut, 2 and 7/8 of an inch, you want the other one 2 and 7/8 of an inch. But if they're a little bit longer than 3 inches, that's not a problem. As for the horizontal tube on the landing gear, that needs to actually be just under 6 inches, because if it's actually 6 inches as we call for it, it doesn't fit in our assembly jig. And then you have to like take a Dremel, bring the miter saw back out to trim off that last little bit. So definitely cut a little bit less than is called for on the horizontal tubes. I guess long story, medium. And we'll have more context for the assembly jig in a moment. So I cut it longer there, and I'll show the problem that we're gonna run into. That's a purposeful promise. And this one I'm going to cut down to less than 6 inches. So these are not going to be, or noticeably not going to be the same length. You don't need to quite go down to 5 15/16, but just about. Closer to 5 15/16 than 6 inches is going to make your landing gear assembly process much smoother, at least with the landing gear jigs as they're currently designed. If you don't use a jig, then it doesn't really make a difference. And let's see how noticeable. Yeah, you can see again about 1/16 of an inch off. So again, that's probably cut shorter than what it even needs to be to fit in our landing gear jig. But again, that one's probably just too long to fit. So it's a somewhat tight tolerance, but still some wiggle room. So you don't have to be exact. All right, now with those 6-inch tubes cut, let's do the 3-inch tubes. All right, just continuing the same process, marking with tape, making the line right on the left side of the measurement you want to make, in this case 3 inches. Putting my hand right where, you know, I've been dumping out the fiberglass dust, you know, a big brain genius. I want to, like, be washing my hands later today. Why are they so itchy? And I did not cut close enough to the line. Again, like I said, these don't need to be as exact to work within our landing gear jig. You just want to make sure whatever length they are cut to, they're symmetrical for that same pair. You might be able to see it on camera, you might not, that they're not quite level. That would work and still make it probably imperceptible as far as the landing gear being level, but if it's too far off again in the same pair of the landing gear, then you'll have one side, you know, kind of off level. But just since we're already out here and
What
have
would you
the
say
saw,
is the acceptable tolerance?
sub-millimeter. And really, I would say for these, like, ideally a 0.5 millimeter, but this is definitely not like the most precision of any sort of like engineering, at least in its current form. I mean, it does definitely require some, right? But we've even gone a little too far there. Did you go too far? Never. No, perfect. All right, I think we are done with all the boom arm cuts we're gonna do. So let's go ahead and actually get to the assembly using the 3D printed parts. All right, we are back here inside the iVue Robotics workshop, and we are making some landing gear. We have our trusty assembly jig pieces, both the vertical piece and the horizontal piece, as Coven was just explaining. They just slide in nice and easily together, like so. Nice and easily, just like so. So it is a tight fit, but it will help keep the tolerance where it needs to be. All right, so let's see which is the longer of the two tubes. And before you actually glue any of the pieces in, you want to make sure that all of the pieces fit as they should, especially this horizontal tube, as I previously mentioned. And I thought I did have all the pieces here. I did not. Of course, we're not building an extended landing gear, which you would use two 6-inch tubes, hence the longer, taller vertical piece. Again, we're just using the standard landing gear assembly jig with a 3-inch tube. And then the extended landing gear, they also have a different main bracket piece, is what we call this. Let me just get that for reference. So these pieces by and large look the same for the standard landing gear and the extended landing gear, except the angle the tube comes out is at a different angle. So if you lay them side by side, you can see this one's pointed more at an angle than this one. So otherwise, the assembly process is exactly the same. Let me put this back up. I just want to make sure. Okay. Yep. Steeper angle is the standard. It is so easy to get those mixed up if you're not paying attention. And so we've had it before where we go to build a landing gear and it's a standard landing gear but has an extended piece and it like doesn't line up properly, and it's like, oh yeah, no wonder. All right, as far as the epoxy or glue that we use to put these together, typically we use Gorilla Glue epoxy. Now, we have used the one with a black handle, but I just went over to Home Depot to pick up a set, and I actually found this JB Weld Clear epoxy, which seems to have all the same properties as the Gorilla Glue equivalent, but you could just buy it in larger volumes, and quite frankly, and easier to work with form factors, especially being 2 parts. I never had this problem. Kidding. But especially with some of the interns who have helped us on the assembly, it's easy for these to not come out evenly, and you really need to have them come out evenly to get like a solid bond, especially a fast-acting bond. So if you're familiar with using epoxy, this is a good, affordable option. If you don't need a lot, you're not doing a larger scale production or assembly, but this might be better. For our purposes, I can also get you more information. We did buy some even larger volume epoxy before, but it was more expensive. It was like higher end commercial grade, I think a little bit more fast acting. But it was just really overkill for what we needed, so we just kept with the Gorilla Glue. But this is definitely, I think, maybe even for relatively moderate scale production, probably going to be the best bet, but you know, maybe still larger volume, you know. But in any case, let's go ahead and do a fit check like I mentioned before. We actually go ahead and do the assembly with epoxy. And so all of these pieces have by and large been processed of support material. That foot still has some support material in it. You could see still some support material in there. Of course, you can take it out ahead of time, or you just even pop in the tube, and there it came out the other end. It's like people, in one end, out the other. And similarly, no more support material in there. All the pieces look to fit just fine, but what? It's not going in! And that's where the problem of cutting it down to 6 inches exactly comes into play, right? Okay. So we could just update the assembly jigs, you know, haven't done that. We just started cutting the tubes shorter than 6 inches. So now we use this tube, and watch this one still be too long. Wouldn't that be funny? Nice and snug. Yeah. All right, so now we know it's going to fit. If it's not coming off easily, we designed the assembly jig so you could pop it out from the other end as well. especially helpful if you're trying to like produce many of them, but you only have like a couple assembly jigs to work with. Otherwise, you can pull it out and then kind of move the pieces versus pushing it out from the bottom. All right, we only need one of those.
So is there any ratio for mixing
Yeah,
A and B?
even, so
Even?
50-50.
50,
And
okay.
that's again where the problem was happening with this epoxy. You would push it out, and then one side, you know, like it would come out, the other
Yeah.
side wouldn't come out, and then you're just wasting so much epoxy, and ain't nobody got the time or money for that. Little goes quite a long way. One thing about this epoxy compared to the Gorilla Glue is the two parts look closer in color than the two-part epoxy, Gorilla Glue epoxy looks, but you can still see the separation line.
Okay.
And so that's, for our purposes, close enough to 50-50. And we're just using wooden coffee stir sticks. You can use anything of the like. Mix it up. I think they say for a minute, you know, once you just see it's all mixed up, you're good. And then you don't want to apply it to the tube itself. You can, theoretically speaking, but going inside the 3D printed parts, make it so you have nice, cleaner pieces. And kind of like eating spaghetti, you want to kind of twirl the spaghetti around the fork or the epoxy around the stirring stick so it doesn't drip. It's all these little practices that, like, as I'm sure you guys know, like really add up that you don't think about, you know. Especially when I go to try to like, hey, you want to help make some landing gear, and it's just like second nature to me, and then I realize, oh no, you got to like kind of work through all of those individual little best practices. All right, so once one foot is glued in, then we're going to apply the glue to the middle piece, but you want to kind of make sure that the middle piece is somewhat in the middle, because if you start applying glue to it, there's a hole through the center, and so you don't want this piece rotating, right? And we used to not have this pass-through hole, so you would have to like just apply the glue on the tube and then like slide the piece onto place, but that would make unless you were like really careful with how you applied the glue, you know, just like a messy, like not refined looking piece, right? So now with the pass-through hole, the epoxy not just holds the vertical tube in place, but it holds this T-bracket piece is what we call it, in place on the horizontal tube as well. And so to maximize the surface contact, you just want to rotate this around a little bit so the glue gets spread all the way across the tube. And then again, just want to make sure it's lined up in the center. Don't actually have to push it all the way in like I did there. And I typically do these three pieces with one, I guess, mixing of epoxy, because if you're not acting quickly enough, it will dry up and it won't be as effective. We might be able to get all the pieces out of this batch though. All right, so all those pieces are in, and now we need to attach the vertical part of the assembly jig. And you can tell if you attach it before you already have this piece pushed in, it won't allow you, and you'll make the landing gear at the wrong angle. So I think this has already been updated, maybe with this version, but we have, as you can tell, a couple slightly different versions of the assembly jig. And now rotated into place, then it's pushed in, so now you could slide the vertical tube just directly in. We still have, yeah, workable epoxy. Workable as in it's not like dried up and caked up yet. And typically I won't actually apply this glue while it's in the jig like this, but I'm being careful to make sure it's not dripping off to the sides. Alright. Alright, and then the last piece, we'll add a little bit more epoxy, although, you know what, it's still workable. We're gonna go all the way. Can't believe it. Can't believe it's not butter. It's JB Weld. Alright, and just so you guys can see, I mean, it's not like a pool of epoxy in there, but it's definitely kind of coated there on the bottom. Probably not going to be able to make that out well, but. And one thing, one word of the wise, actually just had to fix a landing gear. That this piece goes on the right way, so, you know, technically speaking, you could put it on that way, but you want to make sure that it's essentially flat, you know, at the top,
Okay.
to make sure you have it oriented the correct way. And as the epoxy says, a 5-minute dry time is really just like a minute or two. So we'll let this sit here, but that's essentially a full landing gear. You know, well, you make another one of these, and that's a full landing gear set for a develop air, short of the rubber bumpers that go on the bottom. And these just thread directly into the plastic feet. And let's see, do I have Food Network style? You have a completed landing gear. This one may not be like the correctly built, but assuming it is, the feet and the rubber bumpers just screw in the bottoms there. And like the tubes, these rubber bumpers are also sourced from McMaster Car. Let's go ahead and check it out. Let's see if it's dried. No, not yet. Well, we'll go ahead and set this in front of the fan, but that's a landing gear assembly process for you. And yeah, we'll cut and head on to the boom arms. All right, we are back. We have a cleared off bed plate, or almost cleared off. Just wanted to document this as well, as this will probably be one of the more difficult processes to automate, having someone come in and take off that extra support material. Now, this becomes a lot easier after the bed cools down, but then that introduces another problem, having to wait for the bed to cool down. Or maybe what would be best is have 2 beds for each printer. So you just take the whole bed off, put the new already cleared bed on, and then, you know, you have more time to, you know, clear off this bed without having it slow down your next print.
Okay.
On the fly thinking. All right, and of course I don't have a trash can. Onto the floor it goes, and sorry, your backpack got some shrapnel.
It's fine.
I'm gonna go put this back, and then we're going to start creating a boom arm using the boom arm assembly jigs we have. Now, calling any of our production work a process is a little forgiving, so to speak. And this is no exception. As simple as it is, it's not always done the exact same way. And largely due to the fact of the tolerance, both between the tubes as well as the 3D printed pieces, not always, exact, right? There's very little support material in each of these that needs to be processed, about as easy as it gets to pop out the support material. And then you take the boom arm assembly jig here. Luckily, this was right beside me. You don't technically need the clamp, but this is the way that we do it. And there's a little nub that goes into the slot on one end of the boom arm assembly jig to make sure it's aligned properly. And typically I would have some like small needle nose pliers. These aren't as small as the ones that I was looking for, but just removing that last little bit of support material in the motor mount. Alright. And not necessary now, thank you for those. There's also some support material where the motor is screwed in on the bottom. Again, not technically needed to be pulled out right now for making the assembly, but it will be needed once you want to screw the motor in place. Alright, so the motor mount goes in the one side there, and then I like to get the tube positioned in one of the two pieces as much as I can ahead of time. So it's kind of already started in the boom arm piece. And then you'll notice when you go to slide these in together, especially once you start clamping it, it will want to start bowing. The tube and the motor mount want to start like almost like tectonic plates converging together. And so you'll just need to kind of hold it down at that intersection point. Sometimes you got to be careful with the motor mounts, more so on the Developer Mini where it's a little bit of a tighter tolerance, that the motor mount will actually snap. If like the tube is a little bit outside of tolerance on the larger side and the motor mount is a little out of tolerance on the smaller side. But that's tight and no epoxy, no adhesive is needed, we're done.
Yeah.
Now, it's not always the case where sometimes you can with not much, if any, force, kind of rotate them around. The kind of not production way to do it, but if you're a DIY builder and just want, a cheap and easy option, put a little bit of tape around the fiberglass tube where the motor mount or the boom arm mount slides on, and then that will add the friction that you need without it being as permanent as a glue, either epoxy. The CA glue doesn't really work too well, if at all, on the fiberglass. So again, the epoxy works, just ideally not necessary, right? Because it's just another step that if you can cut out, right, best to cut out. We can do that again, but I think that's fairly straightforward. Any questions about any other comments that you would add? I mean, again, pretty...
No, but in an assembly line, would it be easier to just say epoxy every time, or?
I mean, ideally, we get an assembly line, no epoxy every time.
But for us, we just print it out as is, and you said sometimes it's just loose, out of tolerance. Is that just like printered, like?
And again, every part, even these tubes, right? You go to McMaster car, they have a tolerance rating, and so it's both, right? Just we don't live in a perfect world.
Right. Yeah, we'll just have to see what's possible.
Yeah.
If we can make
Yeah,
it
I
friction
think
every
over
time.
time it will definitely be possible to get the friction fit, locked in pretty much every time, and
Okay.
it's just gonna take some fine tuning. I think that's it for this section. Obviously, this is not a full assembly. We still have the lights and the motor to attach to that. So we'll probably scoot this up, and then I will do some soldering here at this soldering station, and we'll try to get that recorded. All right, we are back here to finish the boom arm assembly with a motor. We're going to do some soldering. We're not going to do the full light assembly, but how we would do this typically is a little different than if you were to do this DIY, and different how we're going to do it moving forward, scaling up production. We just have a whole bunch of inventory of these lights that already have these thicker wires soldered onto them. So typically we would just cut them off where the wire meets the prongs of the LEDs, take off the excess heat shrink, and then solder them onto these properly sized wires, which already have the crimps and the connector at the end of them. Or actually, yes, and the way we buy them, they already have the connector on them. Versus these, we would have to crimp the wires and then add the connector, and the crimps are too big to fit over this gauge of insulation. So that's the tidbit on the lights, just to get a quick look both sides, the orientation. There is also a flat side of the light. So the flat side of the light has the black wire, and then I guess from right to left, because that's the order that makes sense, black, white, red, yellow. Or if you're starting from the flat side on the left, again, black, white, red, yellow. On the connector side, if you're looking at the side where you can actually pull up the tabs if you need to take out any of the connectors, from left to right, yellow, white, red, black. So they don't stay in the same order. You can see there is some overlap of the wires. All right. We also have these cut down to different lengths. I think there's one that's 5 centimeters long, one that's 6.5 centimeters long. I'm trying to read off the paper behind Kartik there, but 10 meters long, 13.5 centimeters long, 7.5 centimeters long. Again, if you're doing it DIY, we have some material up online to show you the length to cut these to. But you can also just kind of do it as required for your build. All right. Opening up the motor. So theoretically, for this base model Develop Air, these didn't always used to come this way. And they would be too short, and they all came with black wires. But now you can see they already come with the wires of a length that we need, and already with the color coding that we need. Versus these motors, they came with all black wires. We cut them and then soldered on the colored wires as we needed. So I wasn't sure about this. Kind of nice for, again, scaling up production. One less step, and then fewer parts that are needed, because these are actually fairly expensive. If you're just building one, not so much, but it's like when you produce anything, even like the components that or screws that are 3-4 cents, add up. I think each of these wires are about $1. So
Oh.
yeah.
Yeah, that's pretty. It's pretty expensive.
Yeah, and it might be like 70 cents or something like that. Because I think it's like at $2.20 for a 3-pack.
Okay.
So,
They're also not meant to be sold at scale. They're meant for like one-off, like hobby, like remote control airplanes or something like that. So
but yeah, for a DIY development drone where we want you to do upgrades and repairs, and yeah, it's certainly handy having the color coding. Let me see if I can source a motor without the color coding already. All right. And you can see these motors actually used to come with shorter cables, but now they come with excessively long cables that we need to cut down to size. And this is not at least a measurement that I think we have clearly documented. And those that are very observant, we are using a slightly different motor than what we actually use, but form factor, it's all the same. This is just a 775 kilovolt motor versus the 515 kilovolt motors we use across the XE and the HP. Get out your favorite candy, as we call her. Stripper name.
What's the rejection rate for poor or misaligned joints?
Zero when I do it, no. I don't know. I would be making up a number if I told you. We've only had the one notable solder joint failure. Very
I'm
expensive.
talking about these.
Oh, like with the glue?
Yeah.
I would say maybe one in a dozen, maybe.
I think that's a pretty reasonable estimate.
So I'm going to make sure our soldering iron is heated up and not going to use any helping hands. This is a pretty easy job. As we were talking about off camera before this, this can also be greatly expedited if you're doing a lot of motors, and even for just one develop air, it might be worthwhile to have use a soldering pot if you have one. I wouldn't recommend going out and buying a soldering pot if you don't, but.
That's a good question. What's your current cost per kilogram of filament? 16?
What, it's like 1.75 kilograms per spool. Can you grab one of those green boxes over
You
there?
should be getting 1 kilogram spools unless you're like buying a building.
They might be 1 kilogram spools now that I think about it, because I think it's like 1.75 millimeter filament that I'm thinking about, not the,
Yeah, that makes sense.
yeah. So yeah, 1 kilogram, that's, call it about $30, although, you know.
30? Damn.
With shipping,
it is
yeah.
glass fiber, okay.
But, yeah, in the $25 to $30 range, including shipping.
And if you're making a print farm with like 10 kilogram rolls, you could cut that down a lot.
So I did not really talk through these first two as well as I should have, but what I'm doing is called tinning the wire. So basically just twisting the copper so it's not frayed. And rubbing some flux around the edges. And the flux basically just helps the solder soak through, seep through all the copper strands and makes a nice clean solder joint.
The bill of material cost per drone was like, what, 860?
Yeah, rounded up to the nearest,
Okay.
yeah, not full dollar, but nearest 10. All right, then we need to repeat the same process for these 3 wires. And to get the length, we're just going to copy this existing motor. And let me get a ruler just to measure it so it is documented, at least here in video form.
You guys don't make PCBs, do you? You guys can't make PCBs, can you?
Like the actual, like the.
Like the
yeah,
wafer?
stereolithography, yeah.
Oh, we don't have that machinery for that.
Okay. We'll
Sadly.
have to get it from China. It's not a problem. I was just wondering because we outsource.
Ah.
All right, 6 inches is where we are going to make the cut, roughly speaking.
No, I think if we just gave you drawings in CAD of all the parts and then the videos on how to assemble everything, that should be
Yeah.
yeah.
Yeah, it'd be adequate.
Okay.
Yeah.
Yeah. And if you guys have any questions or stuff like that, we can you guys can always reach out, right?
Sure. Yeah.
Maybe one day you have to come there and you have to show it. Then everything goes good.
Yeah.
Yeah.
I have no problems with
Awesome.
Yeah, I'd love to check out your plant.
going wherever.
Mm-hmm.
You're gonna be taken back to ancient times when you get to our plant, but yeah.
How old are you guys? Or the plant?
Plant itself is like 48 years old or something like that.
Okay.
They
Right?
have
do that.
started in 1947, I think.
Yeah, 1947.
Okay,
That's,
Dave.
they're more than 60 years old.
Wow.
I
Back in
don't
the
even
time
need
of vacuum tubes and
Yeah, basically. That is where they're coming from.
All right, so I already tinned the black wire. I stripped the other 3 sides. These would just be needed for the electronic speed controller, which we may not get to, at least not part of this session. So I'm leaving those off to the side without tinning them. Need to add some flux to this blue wire, the end of this blue wire. And sometimes you'll notice if you're not careful, when you're adding the flux to the wires, you may fray them. So you may want to wipe off the flux, retwist them, and then be a little bit more careful in adding your flux to make sure you don't have frayed wires that get soldered into place.
You know, this is a good question you have at the end. What's gonna cost you to like set up like assembly line for this?
All the money.
What the
And the biggest cost is just setting up like a 3D printing farm to like get all the prints. But even that, you can outsource to other 3D printing farms that can give you like parts on like like a per part cost instead of you having to like take all the overhead. Just an idea. If you guys were to scale, it's probably gonna cost you more than it's worth. But yeah, you guys wouldn't have to like buy 20 printers and
Yeah. We'll see.
yeah.
One more question. Like,
Yeah.
these motors already providing the enough wire, right? Why can't we join this directly to the board, like instead of these things in the middle?
So yeah, we started doing that, but to make them easier to repair and just like upgradable, modifiable, it's easier. So you're not asking people to do soldering, which soldering is like a.
But soldering too much time, like too many times, it will take so much time compared to.
Yeah, the way that I look at it is we take on all the complexity to make it simple for the customer. And so just having the bullet connectors makes it very easy for them to, again, do any repairs or upgrades or modifications versus them having to, effectively learn how to use a soldering iron.
But if they got any issue, they will complain to us, right? We will gonna fix it, but they won't do anything on the drone. So
I mean, we have had some people do their own repairs and rebuilds, and so I mean that's the whole point of it being a development platform. Now, like we bring Omnibot Air to market. No, people aren't gonna be expected to do any of their own repairs, right? They're just gonna want to send it back and probably get a new unit, and then we take in their unit and sell it as a refurbished model.
So this product, more than being like a polished like iPhone type capacity, it's more like more like an NVIDIA Jetson or like something like that where you're supposed to like develop on it.
I mean, quite frankly, it's more of almost like a video using the video game market. Before Sony comes out with the next PlayStation or Nintendo comes out with their next Nintendo, they make development consoles that they'll sell to developers that are oftentimes nothing like the actual console that they're going to sell, other than like a common architecture for them to start developing their games or whatever controllers or peripherals. And so that's what Develop Air is. It's just, you know, we don't have the actual consumer prosumer drone
Yeah.
that, hey, you can develop a module, test it out on Develop Air, but then go to sell it for Omnibot Air where there's a much bigger market.
That's what we're moving towards.
Right.
Yeah. So that's why we want to like keep the motors modular and stuff like that, so you can unplug it if it burns out.
We
Yeah.
want to make drone development as accessible as possible, and that's why we do the bullet connectors.
Okay.
I
Matter
get
of fact, it's actually initially called Breadboard Air, so it's kind of like the breadboard of the sky, so you can just like plug your own stuff in and make it whatever you want.
Oh, okay.
Yeah.
Let your ideas take flight has been one of our marketing slogans.
Nice.
All right, so now we have pre-tinned wires on both sides. So I just have a little bit more flux added on this one end of the motor here, the motor wire, and a little bit different of an angle than I typically take. But just want to make sure it's a nice end-to-end connection.
You can definitely do that with like an automated fixture. To like set that up, you'd be paying more for the automation engineer than the actual like materials or motors.
And a little bit more solder. And I might need to add a little bit of flux on the other side as well. I think I'm gonna do that. I typically do that. I was trying to see if I could save a little bit on the flux. You know, at
A lot of the bigger companies like DJI, when they make their drones, they have like fixtures that just like hold the wire in place at like the correct, you know, position, and then like the human, it's a lot easier for them to just, you know, put the solder in.
Okay.
Yeah. So instead of like what we're doing here by like, you know, having to hold it in place and like, you know, needing four hands, you know.
Yeah.
Yeah. Because that's the majority of the time getting the helping hands to where you need it. Because like if you like set it up properly, then your solder joint's gonna be good, and like that's what we're trying to do here.
and of course we have a heat gun, but at small scale. Lighter is your friend. Burn, baby, burn. And there you have it, one of three. There you have it, folks. You have one fully
I thought it was recording.
made motor. We are back with the same boom arm assembly we've been working on, just to have the motor built out. And even though we made, actually, yeah, we will use this one. It's not an actual motor used in any of our Develop Air models, but it's the same form factor as one. So you just run 2 of the 3 wires in, and then you can run the third one afterwards. And you'll see sometimes they might get just caught up on the ledge there. You just keep pushing through. Worst comes to worst, you can use tweezers to pull them through. Now you can start with any of the holes, and you can see there's quite a few holes on the bottom of the motor. Once you get it aligned, it's fairly easy to see which ones you need to use. But I start with the bottom right, and you want to use that hole as basically your guide. The bottom right hole in the motor, you want to line up with the bottom right hole on the motor mount. Good screwing practice, good screwing technique. Opposite corners, even though there's no corners, I guess, on a circular motor mount, cylindrical motor mount.
Yeah.
All right. Got the motor in. All right, so have the light connector just about pushed in, but you can see it's a very tight fit. Not to say you can't do it all by hand. However, I typically use the end of tweezers or this little putty little spatula tool and just push in on the connector. Sometimes you gotta do it from the top and the bottom, and I'm gonna do it in a way that I can see it better, although the camera may not be able to see it, and just pushed it right in. Now, if you are doing a repair, or you messed up in this process at all, you do have to take the connector off. At least it's a lot easier to get the light back out if you take the connector off, and I'll show how that can be done in just a moment. And of course, running into a problem I typically don't run into, getting this connector to turn. Might take out the motor.
Would this process be easier if you did the light first?
It could be. Again, we don't really have that process standardized. Let's see if I can just push it in a little bit further. Right.
Do you guys use any 3D printing at Motor Specialties, or?
No, we don't.
No,
have
we have
anything right now.
to buy some probably.
Gotcha.
Yeah.
That would make sense because you guys like well, they make a
Just
profit
using
by selling motors at
tweezers.
scale, right?
I mean, we're stuck in the 1950s and 60s as of now,
Oh,
but
yeah.
we're getting there. We're getting there
Yep.
in terms of machinery and tooling. Going a little bit into the future.
All right, and there is a full boom arm assembly. So it got the light. Now that can be epoxied in, but again, just from a repairability perspective, you don't really gain extra value by it being epoxied in. Maybe then a slight aesthetic, sort of increase. But typically, you can even just get it seated in nicely without it being epoxied in. And it's not going anywhere, even if it's not epoxied in. It might just be at like a slight angle, slightly tilted.
Okay.
So I am just taking the CA glue and applying it along the bottom edge here, where there's the most surface contact. And there's like a little keyed spot to line up the GPS dome with the top cover. And then I'm going to add a little bit more CA glue on the opposite side and along these ridges, and you shouldn't need any more than what I'm applying.
Again, mostly just useless people. Yeah.
All right, and I mean, it's pretty much already dried enough that we can install the GPS. Just gonna blow on it a little bit. All right, and then I'm just placing the GPS dome, aligning it with the standoffs for the screw holes. All right, look at that. Easy peasy. One. There we go, there's two. And now we did kind of skip a step with these GPS domes. So let me see if I have one new in box. I may not, but they actually come with like a plastic enclosure.
We don't use those though. Oh, you mean the step of taking it off?
Yeah, here we go. And so on the Developer Mini, they sell a slightly different version of these GPS units without the plastic enclosure. So, we don't have to take another step of removing those screws and then taking like an X-Acto blade and then just popping it out of the casing. And this is the unit that you get as a result to pop it out of the casing. And currently, Developer is standardized with the M8N GPSs. This will be changing though to the either M9N or M10 or a micro or mini version, but the assembly is going to be by and large the same as it is already for the various GPS dome options we have. So yeah, we are back with the MLRS radio. This is made by Matex Sys, the 900 megahertz receiver MR930. So they had a smaller version of this that has been discontinued. Didn't have a USB connector, so it was kind of a pain in the butt to work with, especially to update the firmware. You had to use jumper wires into some of the pins and then plug that into a computer using like an FTDI cable, a serial cable, versus just plugging in via USB. So we've started to standardize using these even across the Developer Mini now, where we were using these across all the larger Developer models, but figured let's go ahead and just make it simpler on ourselves, and it turns out at least enough other people had problems with doing the firmware updates on the other ones that they just discontinued them. Alright, we have a sample unit here with the heatsink already installed. The antenna is not attached. We have the antenna cable here with the antenna, but we'll take care of the soldering first. And I am going to believe this one is done correctly, even though I'm not 100% sure. I guess I can, Roger, if you don't mind passing me that developer, I'm gonna see if I can take a quick look, even though it's covered in heat shrink.
There you go.
Which I still have not grabbed, but we can quickly grab it as we are finishing up here. Yeah, I'm just gonna pretend that's right. Alright. It is, in my experience, better to do this without the heat sink already on. Especially if you're using alligator clips. The alligator clips can sometimes fail to get a good grab around the heat sink, and then you have less surface room, less real estate to work with. Alright, and then these are cables that come with a lot of the Holy Bro components, like the flight controller and the GPS. So you have a whole spare bag of these, and you just want to make sure it's one of the 6-pin connectors. Now there's these GH connectors on both sides for some of them. I think this is an SH connector instead of a GH connector, but we only need this one side anyway, so you can disregard this side. They're not commonly used anymore. And we only need 4 of the 6 wires, so before we cut these wires, we're going to go ahead and pull out the ones that we don't need using our handy dandy tweezers here. So just taking a look at our example radio, we're going to start from the power, and then we have 2 wires right next to it, and then we need to remove the next 2 wires and then keep the ground wire on the far end. So you just need to take little tweezers. These are probably even cables that we can get pre-made with just the 4 connectors in. But again, just with the scale we operate at, makes sense just to use the inventory we already have. Alright, so those 2 wires are removed from the connector we're going to keep, and now we can just cut the wires to the length that we want. We don't really have a standardized length, something that we probably could and should standardize, and then actually have a standardized mounting location for the radio inside Develop-Air, but right now you basically just sit it wherever there's space. And now, similar to what we did with the motor wires, we're going to strip the ends of these and then tin them to the best of our ability, even though these are a little bit more delicate to work with. Smaller gauge, or I guess higher gauge, smaller wire. Alright, and these pins are labeled on here. You might be able to see it in the camera, but red goes to V for voltage, which basically means power. All right, and I'm gonna show my dexterity, maybe lack thereof here. Nice. And just applying a little bit of flux to the pad. And I find taking advantage of these through holes is really nice. That way you don't have to worry about laying the cable flat and then having interference from some of the exposed wire touching some of the other pads. So going through the bottom, up. All right.
This isn't your bottle, is it? Okay.
Ground. That's actually probably good. It's just a little light on solder, so I'm gonna fill up the pad. All right. I'm now using our sample, going over from the voltage red wire just to the next one over, and it is going to RX1. And here I need to strip the end of this wire, put Candy back at work, another shift on the clock. And the last wire just goes into TX1. Nice. Not the prettiest radio you'll ever see soldered, not the ugliest though either. And all we need to do here for this radio on the hardware side is add on the heat sink and the heat shrink, and then we are free to do a firmware update. All right, we are back to finish up the top cover assembly. We just updated the firmware at mlrs.xyz/flash. Again, we have a video. If you want more specific directions, look up the MLRS video on our YouTube channel. I think there's a few different videos with MLRS in the title, but it should be fairly apparent. And just roughly speaking, cutting the heat shrink down to the length to cover the entirety of the radio, or just about the entirety of the radio. And then we have the antenna. We're going to pop that on before the heat shrink gets shrunk. All right, and now the heat shrink is all shrunk. Just nice and simply slide the antenna connector through. There's 3 pieces. I'm only seeing 2. Yeah, so I have the washer that goes in, and then there's that split nut, and then there should be a hex nut as well. All right, so there's the washer, there's like the teeth go up, and then there's the split nut that goes on next, and then the hex nut. And I am just going to hand tighten this. However, best practice, probably use a wrench. Or you got callous hands like me, you don't need a wrench. All right, and then just make sure we have used different versions of these antenna connectors and antennas. So these antennas have the prong in them, where sometimes you can get the receptacle end that have the prong in them. So you just always want to make sure you have a matching pair. If you have the antenna with a prong, you want the hole in the receptacle. And if you have the antenna with the receptacle, you want the connector with the prong. Thank you. All right, and just screws on. The last thing that we need to do for the top cover is install these light pipes at about 70 cents a piece for 3 little pieces of plastic. And we're going to get out a coffee stir again. You could also use a toothpick. We've used toothpicks before. Just, I don't know, whatever disposable little stick you have handy. Disposable being. And a little goes a long way. Just go around the bottom edge, and that will be enough to just catch on the GPS dome. There we go. And I find it helpful if you grab it by the edges so you minimize, if not totally avoid, getting some of the CA glue on your fingers, which not the end of the world. You definitely don't want to spill it on the ground because it can and will create a chemical burn on your floor, especially carpet. But getting a little bit on your hands, while it may make them sticky or tacky, nothing that won't come off with good hand washing. All right. There you have it, folks. One beautifully assembled top cover minus some of the 3D printing defects using an older 3D printer bed. I guess that's another kind of word of the wise, that the printer beds are, I want to say disposable items, but you know, they wear. All right, we are back here with 2 Develop Air models, an older Develop Air base model. I say older because it uses discrete ESCs versus this Develop Air HP uses the newer 4-in-1 ESC. So when you were asking about the soldering for the bullet connectors, that used to not be a thing when we first started using these. We did solder the motors directly to the ESC, but before then, we were using these discrete or individual ESCs, already had the bullet connectors on them, and then the motors, of course, already came with the male end, so it was literally just plug and play. But then you have all of this extra space and weight compared to the 4-in-1 ESC, right? Because you need one of these per motor. And where this ESC uses a special communication protocol It's called the one-wire protocol, like it's proprietary to the company out of Germany that makes these, called FETTech. And so they call it one wire even though it's 3 wires. It's because you have a ground wire, then you have a telemetry wire, and then you have 1 wire for all of the motors. So the data that's sent to all of the motors is done through 1 wire, but then there's a telemetry wire to get that information back from the motors, like you were talking about, the RPM, the temperature, all that sort of information. So this is a lot better. Even you can tell when you go to spin up each of the motors individually in the software, just to make sure they're spinning up at all and then in the right direction. If you're using the exact same motors, everything else exactly the same, but you're using these discrete ESCs, you have to spin these motors, or at least these motors, up to a minimum of about 17% before they will even kick on. Where using the 4-in-1 ESC with these same motors, these will kick on as low as 3-4%. So you just have more control over the motor, right? More precision. And then of course the weight and space savings, and then also the cost savings as well. These boards are about $40 versus you needed 4 of these, each $20 to $30 for the larger ones. So all around, minus more soldering, just so much better to have the 4-in-1 ESC. And then again, from the space savings beyond the size of the ESC themselves, there's also the connections that plug into the PWM breakout board. So you can see on this developer base model, almost all 16 of the connections are used. There's 2 available here on the IO PWM outboard, and then there's the FMU PWM outboard. So the IO FMU PWM out, that's where all of your motors are connected. And so with a quadcopter, you're using connections 1 through 4 for each of the ESCs connected to a motor, right? So if we're looking at it, this is the front, this is motor 1. And so then ESC 1, you should be able to then trace back to the first connection that's labeled 1 here. And then on down the list, 2, 3, 4. If you had a hexacopter, you would use up to 6. If you had an octocopter, you would use all 8 of these for your motors, right? Yeah. And then this would be for all of your auxiliary devices. If you wanted to plug in retractable landing gears, dispenser mechanisms, any sort of spotlight. I'm recording. Yep. And so basically, these are just available. In our case, we use them for pass-through connectors. So instead of like plugging in your dispenser mechanism, your deployment mechanism, your spotlight or whatever up through the fuselage and like running the connection directly to this board, now you can just run them into the side plate where there's basically extension cables, to connect it to this PWM breakout board. And even though this FMU PWM outboard there is also labeled 1 through 8 because they're the identical component, in the software, this 1 is actually a 9, and then the 2 is a 10, all the way down to 16, right? So you have 1 through 8, and then you have 9 through 16, even though they're both labeled 1 through 8. And this was brought up because Kartik was asking if this was like part of the power system. And so you can, and we do run 5 volts to these PWM breakout boards, and then we actually have them wired together. So there's an extension cord connecting this PWM breakout board to this PWM breakout board, because if we run the 5 volts through a battery eliminator circuit or a voltage regulator, so we're plugging in the battery, right, and we get, in this case, 16 to in the neighborhood of 16 volts. And that would fry all the electronics in here if it just got straight battery power. So we need to actually drop down the voltage to 5 volts. So there's a battery eliminator circuit, a BEC as they're called, or a voltage regulator as they're also often called, that's plugged into this power 1 port. And here we go. So you can see this is then soldered onto the ESC, where there's some of these quick disconnects. So again, that doesn't necessarily have to be there, but as far as upgrades, repairability, because you may want, using the other connector that we give you, to give you, you want connect a payload that requires 9 volts or 12 volts, right? So these battery eliminator circuits are by default set to 5 volts, but then you can bridge a connection on them to change them into 9 volt BECs or 12 volt BECs. So like our spotlight, for example, I think we run at 9 volts. And so we have then another BEC, you know, just via another one of these connections. But beyond the BEC that plugs in directly to the flight controller, there's also a BEC that provides 5 volts to the PWM breakout boards. And so here's the second BEC, right? Here's the one for the power connector directly. Here's the BEC for the PWM breakout board. And with it plugged into connection number 10, then it's routed over to the IO PWM breakout board and then just plugged into spot number 8. And this could really be plugged into 8, 7, 6, or 5. You just don't want to plug it in 1 through 4 because that's where motors should go. Now, this one, you could see no motors are plugged in or no ESCs are plugged in, right? With the 4-in-1 ESC, like I mentioned, you actually just plug this into any of the telemetry ports, and that sends all the signals to your motors and then retrieves all of the information back from them as well. So it's just a lot simpler, cleaner of a connection, given there is firmware that you don't necessarily have to update, but we do update it because they're not shipped to us with the latest firmware. So we update the firmware and then just throw them in. It's not quite as simple as I would like, you know, where they don't have a USB connector, but it's just a connector that plugs in here just like this one does, and then that goes to a USB sort of cable. I guess let's move on from the ESCs. Wanted to cover that. Did I adequately address your question, though, about like the 5 volts, the BECs? Okay. Let's see, what are the other differences here? I think those are the major differences with the 4-in-1 ESC to the discrete ESC. Now, instead of the 4-in-1 ESC, we have what's called a sorry, not a power distribution board. Actually, yes, it is. It's a power distribution board underneath there. So that basically replaces the need for a BEC to provide power to the flight controller. So this has like an inbuilt BEC, or actually, yeah, it does. Because this you can just plug in directly to the power port on the flight controller, and this will drop down the battery power to 5 volts. But then if you want other BECs, then you just solder them in here, versus on the 4-in-1 ESCs, you could see that we just actually soldered them onto the main power lines, but on the bottom side. There. Okay. All right, and I guess moving on to the flight controller. All right, we are back with QGroundControl in front of us. So this version of QGroundControl, built for a Mac, is buggy, at least this specific version, and I have not updated it yet because I've updated QGroundControl on previous Mac computers, and then it doesn't like load properly, it doesn't load the map, and so I'm just keeping with the current version. But you'll see if like I unplug the USB cable, then it will crash the application. Don't run into it on Windows or Android. It's just, again, not a lot of people in the drone space and the drone development space using Apple computers. So here I am, an exception to the rule. And you just interface with it directly using the USB port on the side, or you could plug in a radio to the computer, and then if the battery is connected, you can use the radio built into Develop Air for the connection as well. And so this is where you would do the initial configuration for the flight controller, and then of course, you know, the drone surrounding the flight controller. If we wanted to take off or plan a flight, we would go here to plan a flight, and then we could set like a takeoff point, start setting points around the map, and create like an automated flight plan. But we want to go back to the vehicle configuration screen. And first things first, updating the firmware. You're going to see when I unplug this, QGroundControl is going to crash. And a pop-up will inevitably, there we go, ask me to reopen it. Typically I get to reopening it before it does. And so it's typically just better to use a Windows computer if you can help it, but sometimes not always an option. And with our software being in a web browser, it really doesn't matter. So before actually plugging in the USB cable, I went to the firmware menu and just doing what it says. Plug in your device via USB to start firmware upgrade. And then it detects it. And so by default, again, it runs PX4 Pro, but we're running ArduPilot and have last ran ArduPilot, and we could just update it to the newest firmware version there. Now, if you go to advanced settings, you can also see that there's beta and developer builds as well, but of course, I don't think any of that's really required. That's our lead electrical engineer. He's working with our Develop Air Mini, one of our Develop Air Mini, adding collision avoidance sensors. So right now, just as like an upgrade or a modification you can do yourself, you know, following along the videos that we put out there, but working to make that a standard part of the build. So those will go under the motor mounts. Right now, we're just adding them via side plates.
Okay.
I didn't really have to update the firmware, but it really won't hurt. All like the same parameters and everything already loaded on it will stick. And I already was loading this version because, again, this was just built 2-3 days ago. So it hasn't even seen its maiden flight yet. It was going to, I think, yesterday, but someone, definitely not me, did not forget the screwdriver set to screw on the props. Because these models, once you install the propellers, they just stay on, where our base model, they spin on and spin off, and so you take them off after every flight and put them back on, but at least you don't need a tool set. All right, so that's how you update the firmware, and then from there we have all of our parameters listed here, and not just all of our parameters, all of the parameters that exist that you can set, modify, change, etc. That's not what we want. We want, I'm just going to go from where people should access it, iVueRobotics.com, go to the downloads, any of those download options work, and then you could see base, XE, and HP. We have the bill of materials, but we also have a parameters document. So you can actually go to the tools and then save to file like all the parameters that are on here, and then just copy and paste that over to other units. But we also make it available just line by line, all the parameters that you want to set if you want to go ahead and build it yourself. Or even just for us setting it up and doing the configuration, you can kind of tell what each parameter does based off our notes, right? So we would just go down the list if we're doing this totally manually and type in frame, and then underscore, and then set to 1. Some of these will actually have a English or written value. Others will have a numerical value. If you want to change it based off the numerical value, you have to select manual entry for me to enter 1 and then it actually save. Otherwise, if I were to type in some cases, you'll have like a text box field, and you can enter in a number, but if you don't select manual entry, it won't actually save. So you just go down the list. At certain points, it will tell you you need to reboot your vehicle. And in the case of like the power monitor board, so there's the power distribution board here, but here on the 4-in-1 ESCs, we have a standalone power monitor board to report the voltage and amperage in flight or even just on the ground plugged in. And so when you set this battery monitor to 21, you then go to set battery I2C bus to 2, and that parameter does not exist because you have to reboot the flight controller after you set this one, and it'll prompt you to do that, and then you'll see that parameter exist. So some parameters are dependent on other parameters. They're just not all going to be available. This is the one that you have to use Mission Planner for that I was talking about earlier, the battery status and position lights. So you can set SCR to enable here to Lua scripts, and then Servo 9, which is again using those PWM breakout boards. Like I mentioned here, you would have motors 1 through 4, and then 4 connections available for auxiliary or peripherals. And then this would be 9, right? So that means we want the script that we load on this flight controller to go to port number 9, which is connected to this LED adapter board, right? Where all the lights are plugged in. And so to actually set that Lua script, like I mentioned, you can actually take the micro SD card out and then just load the file directly into the scripts folder. But if you go into Mission Planner, that's a ground control fail-safe. So it's like, hey, I'm not connected to any control software. So I'm basically a rogue agent, you know.
Would this lower the drone, I guess, to back to ground level? Or
so yeah, we have it set up to where it will automatically return to landing or land. Okay. But you can, tell it if you lose the ground control software, if it's on like an automated mission, to just continue the mission, right?
Even without
without connection, right?
Oh,
and so in that instance, you would still have the battery fail safe. So it's not like it's gonna just like fall out of the sky, right? So if it gets to low battery, it will try to return to the landing, the home point, or what's called a rally point. So you could even say, hey, if you can't make it back to the home point and this point's closer, just go land there instead. And then you could also, as we do, once it gets to a critical point, just start landing wherever it's at, right?
Yeah.
Not ideal if you're above a house or whatever, right? But ideally, yeah. And so with QGroundControl, it automatically establishes the connection just when you plug in the radio or the USB directly. There is an auto option as well. And typically we would use that, or you can use it, but we're just manually selecting the COM port that the developer is plugged into via the hub we have here. 3 hours later. All right. And now we go to config and then MAV FTP, MAV file transfer protocol. And this is not as great as it is on a Windows device as well. As you can kind of tell, kind of has like a Windows looking UI. And this version of Mission Planner isn't even like officially distributed. You have to like dig through forums to find people that share the Mac OS version of Mission Planner. And still loading. We might need to use a Windows computer.
The battery?
No, you shouldn't. It's the flight controller is getting power via the USB connection. Okay. So for the lights to come on, you need the battery, but just to set it up, you don't. But we can, just to show the lights do come on. All right. So we're not getting the MAV FTP screen as we should, but you would have a plus icon that would like basically have a drop down of like more folders, and then you would click the APM folder, and then in the APM folder there's a scripts folder, and then you just upload the Lua script into the scripts folder. So you could drag and drop, or you could see here upload, and again, it's not really well optimized for Mac whatsoever. So if you're doing the initial setup or configuration, use a Windows computer. It's not set up for filming. We could use no, Gerardo has the Legion. Yep. But that's pretty straightforward. We do have a video showing that already if there's any ever questions about it.
We are able to spin this motor?
Yeah, so we can do so both in Mission Planner through the setup screen. They call it optional hardware, which seems kind of odd that a motor test would be optional. But so I'm just adding, going up to 9%. I could have just sticked at 5%, but then I could test motor A. And you can see that it's spinning inwards. Motor B, also spinning inwards. Motor C, spinning inwards, and then motor D, spinning inwards. Before I was comfortable enough to just like gently have my finger go up alongside the motor. We would just put little pieces of masking tape, and it would basically be like a flag that would be easier to tell which way the motor was spinning. And then just to show the same in QGround. A little bit better of a UI, at least in my opinion. A, B, C, and D. So pretty straightforward. Again, it's really just following this list if you're doing it manually. Otherwise, again, working together, we'll just have the file that we just copy and paste from one unit over to the next. So should be very streamlined. All right, I'm going to, I think, stop recording this unless there's any more questions about the setup and configuration.